Hello. In this presentation I like to show you the capability of the LTT Smart System with our ultrasound microphones. So at channel number 1 I have the MP30 Ultra, and at the channel number 2 there's another 1/4 inch microphone. It is MP14B. So this is a little bit more cost-effective version. So during this presentation I will show you first the hardware setup. So means we talk here now about this 2-channel hardware, which have maximum sampling frequency of 2 MHz at 24-bit resolution. So the anti-aliasing filters are automatically adjusted. It depends on the sampling frequency. So I prepared already the measurement so far to save time, but here I show you the hardware setup. So means we can set here different sampling rates. Now I have here 2 MHz sampling rate, but we have this sample rate stages. So even 4 MHz sampling rate is here also possible, but I will stay now here at 2 MHz sampling rate. So for each channel we can adjust the type of range input. So now I have here a IEPE sensor, so means IEPE powered measurement microphones. So for this reason I have here this setting, but you can connect here also another sensors like charged coupled sensors like accelerometers or strain gauge based sensors. So here we can set the different current draw for the IEPE supply. So I prefer always to use here the maximum. So range input is here 10 volt. Here we can define the channel text, and here is the sensor sensitivity of channel number 1, and here this is another microphone. The sensitivity is here higher from this microphone capsule. Of course we can save all these settings for measurements or for projects which may appear later again. So the microphone set has been calibrated here at 114 dB. So but now to save time I made this already. In the analysis section I adjust here. So here we can see the sampling rate. The analog bandwidth is now up to 800 kHz. Here the FFT block size is 400, but we can change, but this is now for this presentation that's okay. And here we can adjust averaging methods for different purpose. So for example here for acoustics we have here the overall filter. In case of ultrasound microphones, A-weighting makes not much sense, so that's why that's not checked here, and this also not checked. So here we can, in this section we can adjust the typical sound level meter functions like slow, fast, impulse, and if necessary we can define here the level equivalent, so the LEQ defined averaging time. So for example something like 3000 seconds. So then we would have a long LEQ value. So this is here later necessary if I want to make a level with time analysis. So the graphic is here already prepared. And now if I start the measurement, so then we see here something happened. So this is now here we have the frequency band from 0 Hz to 2 MHz. So this makes not much sense here. So for this reason I will modify the display, let's say to 800 kHz. So now I want to copy this X scaling to the channel number 2. So that means, or to graph number 3. So then I say here X scaling, copy this to diagram 3. So now in the next step, to make very accurate ultrasonic measurements, is necessary to remove the protection grid from the microphone capsule. So I did this already from left and right microphone. And now in this presentation I will use air pressure from compressor to simulate here a white noise in this office. So white noise have all energies, so that means we should get a relatively flat frequency response. Of course we have here the influence of this office, of this room. It's not perfect, but for this presentation it's sufficient enough. So now I will start the measurement and start the air pressure. So this is here now the result of the. So here we have the level with time value from MP30 Ultra, and here from the another microphone. And now of course we have here now different scaling, so it's not yet applied here. So that means I will make the FFT here to 200 kHz. And here the grid 20. So now we can see here this result of the frequency response from MP30 Ultra and here from the another microphone. So here we can see this is much more accurate, and even it went above 120 kHz, so means we can still have here good signal to noise ratio for some comparisons. So now next, if I like to export the data, I just click here to the window once, and then here below we see this Alt and G. So that means we use the alternate key plus G. So means I click once here, Alt G. Now I can export this data set or this data from this time domain sound, so sound level was time. I can export this in the CSV format. So, and here so again once click and Alt G. So now you see here channel number 2 and export to this one. The same I can make here with the FFT. So once click, Alt G, Alt G, and now I can export this FFT window. So in the recent version we have additional feature to export here this FFT windows in one process. So we have here the save button, and now I say here export FFT 1/3 octave or FFT or 1/3 octave to CSV. So means I can check or uncheck here the functions. Here I can use different settings, and then I can export this data in the CSV format. So now I open this here. So now we can see here the datas. So this function is now in the latest release available. So if we can provide this version against upgrade fee, so that this will make your job more smoothly. So if you already buy the NVH analyzer software a few years ago, so then you can upgrade it. And since 2026 we deliver the NVH analyzer software with USB dongle license protection key. So that's all for today. I wish you a pleasant day and goodbye.